Hello and welcome to this episode of Microchips, and today we're having a look at this customer's Ham International Concorde 3 that was sent to me that is faulty. It's got a few faults on it, so we're going to have a look at these faults, see what they are, see if we can't fix them, and see if we can't bring this old radio back to its former glory. But before we start, don't forget to like, share, subscribe, comment, join the Facebook group, join Patreon, buy me a coffee, all that lot. Have a look at my website, microchips.net, where all my boards are. And let's get started. So here is the Concorde 3. So we switch it on. We've got no sound. We've got no TX. But we've got this telltale RX and TX light, which we've seen before, and this has tripped me up before, and we know exactly what's going to be causing this. So here's a close-up, and sure enough we have an orange LED, so it means the green and the red are on. So we've had this before, we know exactly where to look. Needle's not moving. Okay, I think we know what's wrong with that. So let's have a look inside. See what joys we can find inside. So on first glance everything looks okay. And then I notice there's no audio amplifier. Okay, that would kind of explain the no sound. But at least they've been good enough to leave the space of metalwork behind, and the plastic screw, so at least we can put an amp in and have it correct. So yeah, wonder why they took the audio amp out. But looking at the capacitor next to the AVR, and yes, it's released all its juices onto the board and rotted that edge trace away. So that's going to be our RX and TX issue. We've had that before and we know how to check that. So looking on the underside of the board, we've got this pin desoldered from the PLL chip. Interesting. So somebody's been having fun and games with this radio. So I suppose we should just try and fix what we can see and work from there. So multimeter on continuity. We'll just go between the 2 points. And with high resistance. So yeah, it's open circuit. Just bring the meter in a bit closer. Yep, should be a direct short between those 2 points, and it's not. And that's because the trace is rotten. I'm taking the AVR capacitor out. We can see there's not a lot of track left in that corner. So we're going to sort that out. So just put a bit of white vinegar on it just to neutralise anything else. We'll fit a new capacitor in a moment. So there's our wire link we've installed. And there's our new AVR capacitor. Let's see if that's made any difference. So sure enough, we have correct RX TX and the needle's now moving. Not moving a lot, but it is moving. So we're getting somewhere. We've fixed one problem. So it's doing something, but it's not behaving correctly. So let's have a look at our VCO voltage. And it's 5.5 volts across all the bands. That is incorrect. Now is this because our PLL is out of lock? Is our PLL at fault? Is our VCO at fault? No. Can't seem to adjust the VCO, so we're going to have to change that anyway. So I put in one of my standard VCOs and modified it with the yellow wire. And then we have the correct VCO voltage across all the bands. So it's changing with the channels, it's changing with the bands as you would expect. Absolutely fine. So that's another problem out of the way. So it just needs a little bit of fine alignment. So, yep. So low, mid, high, super high. I know all the channels are jumbled up on these things, but it's working across all the bands. We've now got around about 4 watts output, 5 on some of the bands, so we'll try and balance that out a little bit. So on the frequency counter, done a little bit of alignment, and we've got all those nicely within spec. They do move a little bit once it's warmed up, and they are very, very touchy to adjust. But we've got them roughly there, so that's all our 5 bands done. So I took out all the capacitors that I would normally take out around the audio amplifier, and guess what? There's more rot. The trace that's underneath 1000 mic is rotten, and the trace that's underneath 100 mic is rotten. And as you can see from those capacitors, they are crusty. So we've rebuilt the audio stage with new capacitors and a replacement audio amplifier. Obviously we've got our new VCO in there. Let's fire it up and see what happens. And excellent, we have sound, so that's a good start. So we're getting there now. So let's try some receive.
1, 2, 3, 1, 2, 1, 2.
Yep, it's receiving.
1, 2, 1, 2.
Excellent. Let's do a transmit check.
1, 2, 1, 2. 1, 2, 3.
Yeah, working nicely. There's all our capacitors that we changed around the audio amplifier. And that capacitor as well there, that's crusty, so we're going to change that. But whilst we were testing it, we found out that the 10kc step doesn't work. And after a lot of diagnostics, we found out that the 10kc step is actually switching in another wafer on the channel change. And this isn't working. So what I'm going to do is I'm just going to put a mark on the wafers so I can get them back to how they were, should I get them mixed up. And it's actually this first wafer that is our issue. And looking at it, it doesn't look like it's overly dirty or anything wrong with it. So we're going to take this disc out, have a look at the other side. Now, if I'd have had a look at the circuit board a little bit closer, I would have found out that this other side is actually not connected. It's just this front side that we need to look at. But we're going to have a look anyway, see if there's anything unusual with the contacts. There's nothing unusual with the contacts, so I've cleaned it up, put it back in, rewired it, and it was still causing me problems. So as you can see from the schematic, we have the PLL, we have the HC806, and we have the 2 wafers that are switched in. And it's one of these wafers that was causing us a problem. So what I did in the end was, it wasn't actually the disc that was at problem. I actually changed the contact sides around and that seemed to cure it. It must have been something on the contacts, I don't know. But we got there in the end. Absolute pain having to remove the channel change all the time, but you have to do it. So we're just having a look at the receiver. We've got our little piece of paper out. I'm going to waffle on for 10 minutes about microvolts and dB sinad and write it down on our little piece of paper. But yeah, sensitivity is good, absolutely fine. So let's have a look at the final bias. Absolutely way too low. So we're going to bring that up to around about 0.7 of a volt. It should do nicely. Inject a two-tone, have a look on the scope. Looks good to me. Very nice. Last thing, we're just going to have a look at the offsets. What should we say, the carriers? So it shows us we should have 10692 and 10695. 10692 is a little bit out, so we'll adjust that up. Just like that. Well, let's take it on the road for a test.
Give him a shout, mate.
So we're on the Tango Charlie net here.
Okay, Ricky, are you on Stuart? He's Tango Charlie 11 and he's over in Midway.
So I got some great reports off this radio on the net, so I was very happy with it in the end. I showed this video to the customer and he was absolutely happy with it. So, a good repair. So anyway, if you like the video, don't forget to like, share, subscribe, comment, join the Facebook group, buy me a coffee, join Patreon, and we'll see you in the next video.